Hello, I'm Jack. Welcome to my channel, Practical Programming with Dr. Su. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to use two separate pipelines to create 3D surface charts with wireframe. The advantage of this approach is that we can get a wireframe with a true color, including the black color, as shown here. This is impossible if we use previous methods to create a wireframe by mapping the transparent square image onto our 3D surfaces. In this video, I will explain how to use the framework created in the last example to create a Sinc 3D surface chart. Here, we will use the git tool to clone the source code used in the last video, and then make some changes to the source code to build the project used in this video. Now let's start Visual Studio Code directly from Windows Start menu. This is the Visual Studio Code interface. Now let's start a new terminal window and cd into code folder. In this window, we create a new folder called GPU54 and cd into it. We can then clone the source code used in the last video with the command git clone WebGPU53. After this command, we leave a space and a period. This will place all our source code in the current folder. Now run this command. We can check direct. You can see the source code is indeed in the current folder. Now we can open this folder from Visual Studio Code. Open folder, code, GPU54. Here contains the source code used in the last video. Now open a new terminal window and run npm install. The command to restore the npm packages used in this example. Okay, finished. Now all the installed packages are stored in the node module folder. Next, we need to make some changes to the index.html file from the dist folder. Open index.html file. First, we need to change the 29 to 54 because this is 54th video. We also need to change the here h1 title to Sinc surface chart. Next, we need to change some parameters. Input parameter will keep the color map, but we need to change the scale to the mass color and ID from scale to the color, and the value we can change to 0, 0, and 0. This color is black color. We also need to change the scale Y parameter to dy, and here also ID dy, and the value we need to put a small number 001. Okay, that's all the changes we need to make. Now we can save this file. Next, we need to make some changes to the main.ts file. From src folder, open main.ts file. Here we need to replace the content of this file using new code. Since most code for render pipeline and render path have been already included in the surface.ts file, here the main.ts file here becomes very simple. Here we first introduce the simple surface data and simple surface mass from surface data.ts file, and then introduce the Sinc function from mass.func.ts file, which will be used to create our Sinc surface chart. Inside the create surface method, we create 3 sets of data. You can see first is data is called simple surface data, which contains vertex data, normal data, and color map data. This will be used to create our 3D surface. The other two data are mass and mass2, create using simple surface mass methods. These two data are used to create our wireframes. The difference of these two data, you can see mass and mass2 is the dy for the mass minus dy for the mass2. So one is for the front face, another one is negative for the back face. Here we define the default parameters. We set color map to the jet and mass color to 0, 0, and 0 is black. And also we set the dy to 0.001, a small number. We then call the create surface function to create our 3D Sinc surface with default parameters. This part of the code allows the user to recreate the Sinc surface with different input parameters. This code ID color map here allows the user to select different color map from the drop-down menu. Now we finish the modification to the main.ts file, so we can save this file. Up to now, we have finished our programming. Now we can run the following command from the terminal window: npm run prod to bound our TypeScript code in production mode. Okay, the bound file is created successfully. Now we can click the Go Live link from the status bar area to open Chrome Canary. To view our Sinc surface, click this Go Live link. Here is our Sinc surface with a black wireframe displayed on this page. You can see they give the true black color for our wireframe. You can see from here. You see the black on the back, also the black wireframe. Now you can change the color map and the wireframe color. For example, the color map we can change to cool and also change to HSV and so on. And also you can change the mask color. For example, we change it to the red wireframe. Red and green color mask wireframe, and blue. See, very nice. The wireframe with true color. And of course you can go to white. 111 white. So it's a white color. Now let's change the dy to see what happens. For example, we can set the dy to 0. Now you can see, you still see, depending on the angle, view angle, you can see here the mesh lines become the dash line in some case. This is because the thickness of our surface and the mesh lines is fixed to 1 pixel. They just overlap together, so that's why at a different angle you see the line becomes the dash lines. In order to see a wireframe with solid mesh lines, we need to separate our wireframe from the surface with a small dy. If we set a large value for the dy, for example 0.02 retro, you can see the mesh line is separated from the surface. You see, this looks not good. So we need to set to a small number, 001. Then you can see the mesh line from front and back. You get a very nice looking wireframe. So you can adjust the dy parameters to get a perfect 3D sync surface. So here we just use 0.001. This gives a very good looking sync surface. Up to now, we have finished this example. In next video, we will discuss how to use this framework to create a simple 3D peak surface chart. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.